Welcome to Study Loop.
Okay, so this is a theoretical yield versus, actual yield problem, right? We want the percent yield. That means moles recovered over mole of our limiting reagent, basically, times 100, right? So we basically need to figure out what our limiting reagent was. In this case, they just tell us an excess of nitric acid was used. So we know that benzene was our limiting reagent, right? Because the reaction is benzene plus HNO3 goes to nitrobenzene plus water. Okay. So all we need is moles of nitrobenzene over moles of benzene. Okay. We don't have to consider nitric acid because we were told there was an excess, so clearly benzene was our limiting reagent. We don't know moles of benzene, we don't know moles of nitrobenzene, but we do know grams. Okay, so we can convert grams of nitrobenzene or grams of benzene into moles using the following formula, right? 20.3 grams C6H6. If we want to get rid of grams, we should multiply this by a fraction that's equal to 1, where grams is in the denominator and moles is in the numerator, right? So what's the factor here, right? How many grams are in a mole of benzene? That's what we need to know. And the answer is given by the atomic mass. The atomic mass tells us how many grams are in a mole of a given substance. So the formula mass for benzene is 78.22 grams per mole. Okay. So once we multiply that out, it's going to tell us moles of benzene that we started with. Okay, I'll calculate that real quick. 20.3 divided by 78.22, I get 0.25952. 25952. Zero. Okay, so we know moles of benzene. We know how many moles we started with. Now we need moles of nitrobenzene. Okay. They told us 26.7 grams, 70 grams of nitrobenzene were recovered. Right. And they do tell us the molecular weight of nitrobenzene. Okay, great. Right, so nitrobenzene, C6H5NO2. And we're going to do the same thing. We need to multiply by a factor that's equivalent to 1 with grams on the bottom and moles on top. Right? And that's the molecular weight. Right? What's the molecular weight of nitrobenzene? It's 123.1 grams per mole. Okay. So let's calculate this real quick. 26.70 divided by 123.1. You get 0.21690. Okay. Right, so we've got moles of product and then moles of limiting reagent. That's all we needed to figure out the percent yield, right? We just put product over limiting reagent. If you get a number bigger than 1, you probably did it backwards. Just a warning there. And I will mention something else. In this case, right, our stoichiometric coefficients in each case is 1, right? It's 1 mole of benzene for 1 mole of nitrobenzene. You do have to be careful when, for example, if we were doing a reaction, one example might involve, 2 moles of something coming together. Right? Like if we had 2 of this makes 1 of this. then we've got an issue. We have to say, okay, we have to divide those moles by 2 to properly account for the fact that we need 2 moles of benzene for every 1 mole of product. But in this case, the ratio is 1 to 1. We don't have to worry about it. Okay. So 0.21690 divided by 0.25952, and remember we've got moles. C6H6 doesn't really matter. It's not going to affect our answer, but I like to put units whenever I can, just to keep things straight for myself, and I totally did that backwards. I'm the best. Okay. And yeah, multiply by 100 to get a percent, right? If you don't, you'll just have the fraction, which is fine. But if you want to express it as a percent, you just need to multiply it by 100. And I'm getting 83.58%. Okay. But I will recall that I only had 3 sig figs when it came to the mass of benzene. 20.3 grams, right? So I should only have 3 sig figs in my final answer here. 83.6%. My final rounded answer to 3 sig figs.